Returning to our normal curve, it may require a bit of a conceptual leap to get the idea of converting units of time into numbers of standard deviations. Again, this is something you can only do with PERT, not with CPM. The reason you can is because every activity duration is a weighted average composed of best case, worst case, and most likely. Therefore, the overall project duration is a mean. It falls in the midpoint of the curve. The duration that arises out of PERT, the PERT schedule duration estimate, is a duration that only has a 50% probability because it falls right in the middle of the normal curve. Then if you know the standard deviation, you can figure out, well, how many standard deviations do I need to add to this duration to get a schedule that has a 95% chance of being achieved on time. Furthermore, you can push back. If your boss says, I want you to reduce from this schedule, you can figure out how many standard deviations to subtract from the schedule and what the probability of that would be. And since the midpoint is already 50%, the further you go to the left, the smaller your chances. It's at this point that you may recall the term Six Sigma. Sigma is an expression meaning standard deviation. It's a Greek symbol. So this is plus or minus 2 standard deviations. 3 standard deviations, that's 99% of the curve. 6, that's way out there. That's a vanishing small number. Hence, 6 sigma for very small number of defects. Okay, to continue, even though these statistical terms may seem complicated, calculating them in PERT is easy. We already know the mean is best case plus 4 times most likely plus worst case divided by 6. The variance is what we need to do next. Worst case minus best case divided by 6 squared. That's the variance for each activity on the critical path. Okay, and we only need to calculate the critical path variances. That's the only, those are the only activities of interest because it's the critical path that tells us the duration of the project. So you use this formula to find the variance of each path, each activity on the critical path. You add them together and then take the square root. And in doing that, you arrive at the standard deviation. Okay? So now once we've gotten this far, we know that this project is 131 days and the standard deviation is 3.49 days. So what do we do with it? Okay? Well, if you look at something known as a z-table, you could ballpark this, but to make a long story short, if you look at a z-table, about 1.67 standard deviations is the 95% probability. It's somewhere in this red arrow. So if you multiplied 1.7 times 3.49 days, it's about 137 days. But if you were asked to remove 10 days, you've got over here to the left, minus 10 divided by 3.49. What you're doing here is asking yourself, how many standard deviations is 10 days? It's minus 2.86 standard deviations. So you're really talking about a 2.5% chance. If your boss is pushing you for this, you now have the ammunition to say, hey boss, by your own estimates and your executive team, I've now shown that even though we can try, the likelihood is small. So don't you wish you could say this? We'll certainly do our best to reduce the schedule by 10 days, but according to your own estimates, we only have a 2.5% chance of achieving this. PERT helps you say this. It gives you the tools to say this. So to summarize, PERT can help you get agreement on the schedule by using the very estimates of the management team pushing you for a reduced schedule. Always remember the probability of achieving the schedule built using weighted average of estimates is only 50% because the result is a mean, and a mean falls in the center of the normal curve. Schedule reductions from the 50% estimate drop the probability very quickly. Depends on the project SD, but it really is a precipitous drop-off in likelihood. What you really need is 95% probability schedule. You really, once you've done your PERT estimate, you need to have maybe 1.5 or 1.75 or so standard deviations worth of duration to get a project schedule that has a 95% chance of being done. Plus, I should add, using these ballpark methods, for example, the plus or minus 1, 2, and 3, And you could do this on a whiteboard without even using a calculator, and you could end up saying this. That is the power of PERT, the probability, the predictive approach it allows that CPM does not offer.